That's what we aim. So let's start with the polar coordinates. So first, before we talk about polar coordinate, we have a rectangular coordinate first. So rectangular coordinate, let me see whether I need to record this. Actually, morning I recorded a lesson, I believe. Okay, never mind. So still can record that. So we start with first rectangular coordinate. Okay, so rectangular coordinate is usually a xy coordinate here. So we have a point xy axis here and a point, say x and y. Then you get a point here, pxy. Okay, so you tell people where is x coordinate, where is y coordinate, and location of p. Okay, this is one way to tell. Means this is x here, this is y here. So you get a point x and y, get a point, right? So this is how you tell rectangular coordinate here. Besides rectangular coordinate, there is another way to tell location of a point is use the polar coordinate here. Polar coordinate, the notation is r theta. Okay, so r theta, let me show you r theta. Okay, r, what does it means? R is the distance from the origin. Okay, distance from origin is called r. So you can find r here. This distance is called r here. So tell people how far away from origin. And then the theta is what? Theta is measured always from positive x-axis anti-clockwise. Okay, so the theta here is actually measure from theta measure from positive x-axis and anti-clockwise. Okay, so you can see the direction anti-clockwise there. So this is how to tell location of a point. First, to find out how far it is from the origin, the theta tell you a direction. Okay, so this is how introduce the polar coordinate here. So let's look at example 16. How do we actually find out where is polar coordinate? All right, example 16. Okay, locate where is the point. I sketch the following. Locate the point. So here is the point, the 2 point A here. A is for P. So what does it 2 here means? 2 means R is equal to 2 now. Okay. Distance from origin is 2. And theta is 120 here. Okay, this is what for P, right? So what does it mean? Okay, right. Let's try to draw out the point. So I try to get as accurate as possible now, so you can see for yourself where is this point. Yeah, normally x and y axis, right? Now let's say this is 2 now, 1, 2. Okay, 1 minus 2 here, 1, 2. So what you have, you go first, or you try to r equal to 2 means the distance from the origin is 2. So you can actually draw a circle with this 2. Okay, draw a circle with it. So it means the point is on this circle now. Distance from this circle to origin is 2, right? So this is 2 first, and then you try to find the direction 120. So 120 is wet now, so I use another different color. So this is, you measure from the x-axis, positive axis, right? You measure it. This is 90, then another 30. Okay, so this is 30 now. This is 90. So 90 degree, then 30 degree. So the total is 120 now. So let me write properly. So this is 30 degree. Okay, the other 90 degree. So all together is 120 degree now. So this point here, you join direction now. Let me see how come. Okay, the point is here. Okay, this point is 120. The distance from origin is 2, and the angle is 120. 90 plus 30 equals 120, right? So this is how you locate the point. So this is the point P. Okay, P is at this point. Let's find another point, the point R now. Okay, the point R. So let's draw it. Before that, let's see what is this mean. It means R equals 3 now. Distance from origin is 3. Angle is 330. So let's try to draw the point. Where is it? You have X and Y axis here. Now you draw a bigger circle. Radius is 3 now. So I say 1, 2, 3. Okay, -1, -2, -3. So a bigger circle and radius 3 now. So this is -3 and 3, -3 and 3. So the point is on this circle. Okay, which distance 3 away from the center of the circle. Okay, so here is a circle radius 3 first. Then the direction is 330. So where is 330? So you measure from the positive axis, then anti-clockwise. So then you draw 330 line. So let me draw 330. You should get, okay, so this is 90, this is 180, this is 270, 270 minus another 60 here. So this angle is 60 here. This angle is up to here is 270. Right? Then another 60. Okay. So we have 270 plus another 60 here. Okay. So okay, to 270 until another 60. Okay, and so the point is actually cut the circle at this point, okay, this way intersect. So this point is actually 3,330. Okay, so this is how you locate the point. So you find R is how far this is away from the center. Theta is always measured from the positive x-axis here. Then from there you find the angle. Then this one line and circle that intersect together to locate the point. Okay, let's write that here. Let's try again. Okay, so this example 16. Okay, I show you how to locate the point by drawing the circle, then the direction of a line. Direction of a line always measure from positive x-axis and anti-clockwise. Okay, so now I move on to questions. Before example 17, I introduce some conversion here. Okay, so what is the relation between all these, right? We have start off with x and y. The x and y, so you have a point x and y here. The location x and y now. So if you know x and y, how do you find r and theta here? Okay, x and y already. So locate the point x and y. So this is your y here. So this will give you the distance y. This y can be positive or negative. This distance x also can be positive or negative here. So from here you can find out what is r and theta here. The diagram say r using right angle triangle. You actually Pythagorean theorem, right? You see that r is equal to x squared or y squared. So quite easy to see that. Okay, square root of x squared by y squared. Then you can find theta now. Okay, how to find theta? Theta is always measured from the positive x-axis and anti-clockwise. So tangent theta from here is actually opposite over adjacent. Okay, opposite over adjacent. So opposite of the angle is y. Adjacent is x here. So from here you can find theta now. Theta equal to tangent inverse by x now. However, before you do this, you must check the answer now, because you have to know where is x and y. Okay, you have to know where is x and y, so that your angle is always between 0 and 360. Okay, your x and y, then you check angle between the angle is between 0 and 360, right? And then r will greater than 0. And measurement of theta always measure anti-clockwise. Always measure anti-clockwise. Okay. You'll see that later on. So this part a bit tricky here. So this is given x and y. So this part is given x and y. For x and y, you can find out where is r and theta here. So x and y here, you can find out where is theta now. Okay, so how about the other way around? Let's say suppose your r and theta, you're going to get x and y now. How? Let's the other way around. So suppose I give a point here, this point, this r here, distance from origin, and theta. Okay, theta is okay. Then how do you find x and y here? So y is this one, x is this one, right? So we can find using cosine theta first. Cosine theta is what? Adjacent over hypotenuse. Adjacent is x, hypotenuse is r. So from here, get x equal to r cosine theta. Okay. Now if you do another one for sine theta is opposite over hypotenuse here. Opposite is y. Diagram opposite angle y here. Hypotenuse is r. So from here, you get y equal to r sine theta. So these two formula tell you how to convert. Okay, these two formula tell you how to convert r theta to xy. So x is this one, y is this one. Right? So this is the link between all this connection. So that was this page to you. And go. Okay, I think was this page. 참고소다. Newsletter. Okay, so now we're going to go through some exercise. Example. Any message for me, Norman? Okay, go back. Exercise now. Example 17. And this is a hard example. Change the following in x and y to polar coordinate r and theta. Okay, x and y. So what you're given is x and y now. Then try to figure out what is r and theta from here. So first one is quite easy. So first one, A now. Okay, A now. So draw the point 3, 4. Okay, x and y. 3, 4. 1, 2, 3. The other one 4. 1, 2, 3, 4. So the 1, 2, 3. So point 3, 4 is somewhere here now. Okay, that means that you join the origin and you know that this distance is 4. This distance is y equal to 4. This distance is x here, x equal to 3. Okay, the right angle here. Okay, what is r now? R is distance from the origin to the point. R is the distance from origin to the point. So from here, using right angle triangle diagram term, R is equal to square root of 3 square plus 4 square. Okay, this right angle triangle here. So you get square root of 9 plus 16, you get 5. Okay, so we get 5. Now, how to find theta now? Theta is angle measured from the positive x-axis. So this angle is theta here. So you know tangent theta is opposite over adjacent is y over x now, which is 4 over 3. So the theta you're looking for now is tangent inverse 4 over 3 now. So you press the calculator and find out what is this angle here. So tangent inverse 4 over 3. Okay, tangent inverse. The 4 over 3. Okay, and then you get 53 degrees. Which is reasonable, right? You look at the diagram and draw it for 53 degrees. So this is how you find answer of part A. Okay, where is R? Where is theta? Okay, and that is for part A. Okay, I want to find part B now. Part B, the point is minus 3, 4. Okay, part B, the point is minus 3, 4. Okay, from the part B now. Okay, minus 3, 4. So let's draw the point. Okay, I want horizontal minus 3, 4. So let's see I draw here. Okay, so x and y minus 3, 4. So see minus 1, minus 2, minus 3. Okay, 4 right? 1, 2, 3, 4. So minus 3, 4 is somewhere here. You got a point, minus 3, 4. So you can join to the origin. So you get a triangle now. Okay. What this triangle trying to tell you is this. What is the y now? The y is for plus 4 here, positive, and then the other one, the x coordinate is negative. So this one is negative here. Okay, so what you need to do is find out what is r. R is very easy. It's a distance from here to here. R. Okay, R is this one. Now, where is theta now? Theta is always measured from the positive x-axis, right? So theta in this case is actually which one? It's actually this one. Theta is actually this one. Okay, measure from the positive x-axis, turn anti-clockwise until you get the point. So let's try to find out R first. R is an easy one. So R is equal to, how to find? Okay, right angle triangle, right? So you get actually minus 3 square plus 4 square, right? X and Y. So this will give you 9 minus 3, you square it, you get 9. So this is actually 9 plus 16. Okay. Square root 25, which is 5. So the radius is 5. Okay, radius is 5 here. So this is the radius. Very easy part here. Now, how to find theta now? So tangent theta, we know a formula. Always use that. Tangent theta y over x here, and y is equal to 4. X equal to minus 3. So that means your theta is equal to tangent inverse 4 over minus 3. And then you press the calculator. Okay, 4 over minus 3, you'll find that this is minus 53 degrees. Is it correct? It doesn't look correct, right? Because our theta supposed from 0 to 360. So what is actually going on here? This is not the correct answer. The calculator can give you a correct answer. But what this number tell you is called reference angle. Basically, it's just telling you that this angle, ignore the sign now, this angle is 53 degrees. Okay, if we know the sign, this angle is 53 degrees. So what is the angle theta now? So angle theta, you just look at it, is look at your diagram, you know, is take 180 minus 53 degrees. Okay, take 180 minus 53 degrees, then you get the answer now. Okay, minus 1, 180 minus 53, okay, 127. Okay, so the correct answer is 127. You see how? Because always measure from the positive x-axis. So you can see from the diagram, it's 127. So this is example 17, part D. Okay. Now, let's look at example 17, part C. How to answer the question, right? Minus 5, minus 4. Okay, I move on to part C now. Okay, part C now. Minus 5, minus 4. Okay, this is x and y is minus 5, minus 4. Right? So you can draw the xy axis. So I'm going to draw the black color one. So okay, x and y. So part C, minus 5, x equal minus 5 here. So you get, okay, minus 5, okay, minus 1, minus 2, minus 3, minus 4, minus 5. Okay, and then y is minus 4 now. So get minus 1, minus 2, minus 3, minus 4. So if you draw this, the point is here now. Okay. the point is actually -5, -4. So join it to the origin, and now a triangle. The triangle is this one. This is x equal to -5, y equal to -4. Okay, x equal to -5, y equal to -4, and in a right angle triangle, -4. Okay, so this is actually -4. And so this right angle triangle here. Okay, right angle triangle with the x-axis here. And where is the angle now? The angle in this case, if you draw, it's all the way from here to here. Always from the positive x-axis all the way to there. Okay, to a line. So how to find r first? R is the distance from the origin, or here. So r you can find out is actually square root of one of them is x squared. Okay, so we x squared by y squared here. Okay, x squared plus y squared. X is negative now. Y also negative now. But then because you square it, the opposite number, so this become 25 plus 16 equals square root of 41. So there is r here. Then how to find theta? So you can also use a tangent theta here. Tangent theta is y over x here. Y is equal to -4. X equal to -5. So this simplifies to 4 over 5. Okay, 4 over 5 now. Then you can find out what is theta now, right? So theta is equal to tangent inverse 4 over 5. So you press the calculator, tangent inverse 4 over 5 will give you this. I give you 39 degree. Okay, about 39 degree. That of course 39 degree is too small already. And look at the angle. It's quite a big angle here. How can it be 39? What I actually tell you is this angle called a reference angle. So this angle is 39. It's actually this one. From here to here, this is 39. Okay, so where is this theta now? After you notice on this 39 now, so the angle is equal to 180 first. Okay, go to 180 first, then plus 39 degree. So they come 219 degree. Okay, so this is how the answer here. Okay, so this 119 degree is the correct answer for theta. To example 17, part C. Okay, then example 17 part D, right? Go on this page to do example 17 part D. Okay, so I want to change from xy to r theta. So the 5 minus 4 now, so you can draw where is 5 minus 4. So this is xy here. So origin here, 5 minus 4. So go to here, 5 here, 1, 2, 3, 4, 5. Okay, then there's 5 here. Then go down, minus 4. So, okay, 1, 2, 3, 4. Minus 4, right? So the point is here now, 5 minus 4. So we can join the origin. Okay, join the origin here. This is right angle triangle. Okay, so your y is minus 4 here. So this is y equal to minus 4. Your x equal to 5. Okay, and distance from origin is r here. Distance from origin is r here, always positive. And where is the angle theta now? Remember, the angle theta always measure from the positive x-axis. So how do we get them? So we get from here to here, the theta. From positive x-axis, you go anti-clockwise until you get the angle point here, the direction of the point, the theta here. So how do you find r and theta now? So r, as we show, is actually square root of x squared plus y squared now, which is actually x equal to 5, y is minus 4. So when you square it, 25 plus 16, square root of 41. Same. Okay, how to find theta now? Tangent theta, okay, it's always y over x here. Your y is equal to minus 4, the x is 5. So for theta equal to tangent inverse 4 over 5. Okay, so where is this angle now? So this angle, if you follow calculator, you get minus 39 degree now. Okay, but we don't want this angle negative. We want angle from 0 to 360, right? 0 to 360. So what you get is actually this angle. Where is it now? It's called reference angle. It's just say that if you ignore the sign, the reference here, this is 39 degree. Okay, if we ignore the sign, the angle from there, this is called reference angle. Here is 39 degree. So where is the theta now? So you just know one round is 360. Okay, one round is 360. So short of 360 now. So this is actually 360 minus 39 degree. Okay, because almost get it complete round of 360. Go back 39 degree. So in this one is actually 321 degree. This is example 17. So the correct answer is 51 degree. Okay, for theta. Okay, so that is example 17, part D, how to convert x and y to r theta. Okay, now we move on to example 18. Okay, example 18 now, it's the other way around. Now given r and theta now, you're going to find out where is x and y. The other way around, right? That's now what we have is x and y convert r and theta. So this time, r and theta, find out x and y now. So we'll do the part A first. So r equal to 4. So r equal 4 here. They tell you r equal 4. Theta equal 32. So if you try to draw it, you should get something like this. Draw x and y here. R equal to 4. Try to draw a straight line. What does it mean? R equal 4. That means you have a circle radius 4. So you can take a circle radius 4 first. So let's say this is 4 here. This is minus 4 here. This is also minus 4 here. This is another 4 here. So we get a circle. Which is a circle now. Radius 4. Okay, circle radius 4. We know that okay, the point is on the circle. The direction of the point is 32 degrees. We measure from the x-axis. So you look at this one. I'm going to move down, move up 32 degrees. So from here, I can get a point here, so I draw a point. This point here is actually 32 degrees. Okay, this is part A here. So from the diagram, you know that. Okay, from the diagram, you know that your x is positive. Your y is positive, right? From the diagram, you can get this is also x, y here. X is positive here. Y is positive, right? So this is how to find x and y here. So if you draw a triangle, okay, so this is your x here. Okay, this is a y here. Okay, your x is positive, your y is positive. Okay. Now, from right angle triangle, I can find. Okay, so right angle triangle is actually this one. Okay, this theta, this r, right angle triangle. So this y and x here. So you know that cosine x here, cosine theta is adjacent over hypotenuse side, which is actually x over r. So x is r cosine theta. Okay, like this. Then x for r is 4 cosine 32. Okay, so you get 4 cosine 32. So you get 4 times cosine 32, and you get 3.4. So x 3.4. You can also find y now. How to find y? You can use sine theta here. Sine theta, where's formula sine theta is opposite over hypo, right? Opposite is y, upper is r. So that means y is r sine theta now. So r is 4 sine 32 now. So then you can find out what is y now. So 4 sine 32 here. 4 times sine 32. Okay, wrong way. 4 times sine 32. Okay, 2.1. Okay, 2.1. So you can actually find the coordinate, right? How to get r theta, for r theta, how to get the x and y. So in this case, your x and y are both positive, right? I just want to emphasize that if you convert r theta to x and y, you don't need to worry about which quadrant. The formula will come out correct. You'll see a few times. Okay, this is the first one. Okay, let's look at B now. It's the same argument repeat over and over again. Okay, B now 5, 1, 2, 6 degree. Okay, 5, 1, 2, 6 degree. So I mean draw a bigger one. It's a bigger circle now. So x and y. Okay, 5, 1, 2, 6. So you draw 5 first. So let's say 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5. So this is minus 5 here. I've been getting no good. This one I think scaling no good. Okay, it's 3, 4, 5. Okay, so this 1, 2, 3, 4, 5. So you can do this 1, 2, 3, 4, 5. So you get minus 1, minus 2, minus 3, minus 4, minus 5. So you get a circle. Circle, okay, for part B is a circle, right? Radius y. So you can draw this circle. Okay, circle, radius y, center origin. So you know the points on this circle. And then where is the direction 1, 2, 6? 1, 2, 6 always measure from the positive x-axis, right? So you must measure from here. Okay, so measure from here. This is 90. Then how much you need to go until get 126? So you need another 36, right? 90 and 36, you get 126 here. So from here, you can draw the straight line. So so the point is somewhere here now. 5, 126. Okay, radius is 5, direction is 126. So you can, from here you can figure out, if you draw a triangle, how does it look like? So triangle here, so you find that this is your x here, x negative, your y positive. Okay, your y is positive, your x negative. Okay, so how do you actually find out x and y now? You just use the formula now, just before, right? I have used this before, so I just pick up here. So you get x equal to r cosine theta. R equal to 5. Then cosine 126. You'll check that this is always positive, negative now, okay? 5 cosine 126. So pass the calculator. 5 times cosine 126. And then you get minus 2.9. So fair enough. X negative, right? For the positive diagram. And y positive, yeah, actually write r sine theta I equal to 5 and sine 126 here. So 5 times sine 126 here. You get 4.04, okay, 4. So you get a point x and y now from here. So this is part B now. Okay, let's look at part C. Okay, part C now. I have r equal to 10. Okay, r equal to 10. Theta equal to 250. So let's draw the picture. So I can, this is the x-axis, this is y-axis here, and then I want to get circle radius 10. So let's say I have a 10 here, just 10 here now. usually use a rubber. So I have a 10 here, and 10 here, and 10 here, and 10 here. So you can draw a circle with this 10. Okay, draw a circle with this 10. Okay, you see the point is on the circle with this 10, center origin. Then you find out where is 250. Okay, direction 250. Remember, direction is measured from the positive x-axis here. So let's try to draw 250 here. So this is 90, 580, and then 580 already. I want 250. That means I need to get another 70 degree. This 70 degree here, and this 180 here. So now you try this, cut a point. This is the point you want. Then 250. So from here, you can see that the x coordinate is negative. So if you draw the picture, you'll find that okay, x coordinate is negative. This x here, negative. The y coordinate also negative. Okay, both of them on the left side and downside. So y is negative, x negative now. So this x here, y here. Right. So how do you check answer? You check answer x equal to r cosine theta now. So r equal to 10 cosine 250. So you press calculator, you get negative answer down here. So it's 10 times cosine 250. Okay, you get minus 3.42. Okay, then also your y negative right below the x-axis here. So y equal to r sine theta. Formula for r right here. So it's 10 sine 250. So 10 times sine 250. Okay, 10 times 250. Okay, so that's normally. Okay, minus 3 by 4. We can see that also. By 4, negative by 4. Yeah. So this is example 18C. Okay, example 19C, 18C, right? Okay, last example for this chapter, 18D. See how everything here. Okay, a few people not here. Huh? Okay, I think some of you drop out already. Kugan and Muhammad Zafri, Sarayan. Okay, some of you drop out already. Last example. Okay, let me see the message. Last example, all right? Okay, last example, 10, 300. So you have a x-axis, y-axis here, 10, radius 10. So you say this is 10 here, let's say 10 here. So draw a circle, radius 10 pass through all this point. And the angle is 300, okay? R equal to 10, theta is 300. So where is 300 here? 300 is actually measure from the x-axis, okay? You want to get 300, so you get this one, 90, 180, 270, then finally 30. Then you got 300 there. So this is the point. Okay. Then 300 degree. Okay, so now you can see that the x is positive, y negative, right? Make sure that you get the correct answer. X is positive, y negative. So you can check calculator now. So you get x, because you based on diagram, you know answers should be like that already. So you get x equal to r cosine theta, which is 10 cosine 300. Okay, 10 cosine 300, and see what is this equal to. So 10 times cosine 300. It's very enough. You should get answer positive, which is 5. Which is positive, alright? X positive. Your y will be negative now because this is below the x-axis here. So r sine theta, which is 10 sine 300 now. So based on calculator, times 5, sorry, is 10 times sine 300. And this time you get minus 5 square root 3 or minus 8.7. Okay, so this is last example already. Okay, last example for this chapter. So next lesson I will try to do a tutorial for you. Okay, and what else? You need to do quiz starting from this week, right? So what are the quiz actually here? So this is what you do in the Blackboard. You go to the learning resource, then look for the folder home-based learning. Okay, 2020. So 6 July to 11 July. Then inside there's a quiz. Okay? Inside there's a quiz, and you have 3 attempts to do this quiz. Okay? The highest mark count, okay? 3 as correct. So what is this quiz all about? Is the polar coordinate, rectangular coordinate, what we learned today. Okay? This is a quiz. So if you can do this quiz, you can certainly do the tutorial. Okay? No issue about the quiz and tutorial are quite similar one. Okay, that's final count. I think beginning a few people are here, then the final count on the attendance. Okay. Final count, then attendance have people not here. Soraya, I think it's beginning. I think I was here. I think. Okay, these are the people not here. No, Kugan, Kunalan, and then Muhammad, Safi, Soraya. Make sure that you get the message. You must do a quiz. Okay. So, mark this attendance means these people are not here. No? Okay. 3 people are not here. Okay, I can stop recording already.